Hello, my name is John Kelly and this is the Weber Auto YouTube channel. This is the second in the series of videos on the evolution of the Toyota Prius hybrid transaxle. As you can see sitting behind me here, I have a second generation Toyota Prius. This model was available in the model years 2004 through 2009, which was 6 model years, which interestingly enough was the same number of years the first generation Prius was available from 1998 through 2003. However, the first generation Prius was only available in the United States between the model years of 2001 and 2003, yet it was still a 6-year-old model by the time the end of the 2003 model year came around. The second generation Prius that we have here is greatly improved over the first generation Prius. This particular model here is a 2004, so it's the first model year of the second generation Prius. If we were to look at the back of this vehicle, it has a badge that reads Hybrid Synergy Drive. And the Toyota Hybrid Synergy Drive system was a concept that aimed for a better balance between the power of the transaxle and the power of the engine and the switch over there. They made great improvements in the inverter-converter assembly, made changes in the battery, made significant changes in the transaxle that increased the power of the transaxle. The engine power is pretty much the same as it was before. It's the same engine. They made some small adjustments to the variable valve timing, but other than that, it was the same engine. So the majority of the changes that made the improvements in the second generation Prius were due to the control of the transaxle, and the transaxle in this car is the P112 hybrid electric transaxle. Now in this video we are going to assume that you have already watched my video on the P111 transaxle. There's actually 2 videos I made. I made one that's a quick look that just gives the overall operation of the transaxle, and then there's another one that is the deep dive where we go into all the individual pieces and put the entire transaxle most of the way together. This video is going to assume you are already familiar with the P111 transaxle because we are going to show you the differences between, or the improvements made in the P112 transaxle versus the P111 transaxle. So if you have not seen the P111 video, go watch that and then come back to see this one. So let's go take a look at the major changes and the differences in the P112 transaxle. If we were to open the hood on that second generation Prius, the cover of the inverter-converter assembly reads Hybrid Synergy Drive. And we are going to look at part of what the Hybrid Synergy Drive encompasses in relation to the transaxle itself in the second generation Prius. Now, of course, there's a different inverter-converter, different battery, a whole bunch of other changes that we'll have to address in system videos later on this year or this fall, but for now let's take a look at the Hybrid Synergy Drive components of the P112 transaxle as compared to the Toyota Hybrid System Drive of the P111 transaxle from the previous video. Okay, I've got laid out here on the table components from the P111 and the P112 because I want to do a comparison of what has changed. If you recall from my very first introductory video, I said there wasn't a lot of mechanical difference between the P111 and the P112. So I want to show you what the major differences are and talk about how they've improved the transaxle, the P112 transaxle over the P111 transaxle. All right, so let's start with the stator assembly for MG1, motor generator 1, the starter and generator motor in this transaxle. As you can see here for the P112 stator, the windings themselves are not encased in some sort of a resin like they did in the first generation Prius Transaxle, the P111. It also does not have a temperature sensor built into it. I have no idea why. They added a second temperature sensor over by the MG2 Stator in the P112 Transaxle, and it measures the transmission fluid temperature in the bottom of the pan rather than measuring the stator temperature itself. Once again, I don't know why they did that, but that is a change that they made. I suspect that the encapsulated windings in resin is actually a better way to cool the MG1 Stator, because in the later models of the Prius Transaxles, the P410 and the new P610, they are the MG1 Stator. It looks very similar to that first generation one in that it's encased in some sort of a resin. And once again, I assume that's to help dissipate the heat. All right. So that's MG1's stator. For the MG1 rotor, as the same diameter, it is a tiny bit thinner. And I'm talking half a millimeter thinner, so not a lot. But one of the big improvements they made on the MG1 rotor assembly, which, if you remember from the P111 Transaxle, turns the power split device sun gear up here, is the big change they made is they balanced it better and changed its maximum RPM from 6,500 RPM, which was its maximum on the P111, to 10,000 RPM on the P112. Now, that will allow it to spin at, of course, faster speeds, but faster speeds also can equal higher output voltage, higher power, more current induced into the windings of the MG1 Stator, which is part of some of the changes they've made to the P112 Transaxle. The high voltage battery in the trunk on the first generation Prius was rated at 273.6 volts. And that was the maximum voltage that could be applied to MG1 and MG2 as you would drive that vehicle. Well, they made a change also for this P112, and now they are allowing up to 500 volts to be sent back through the inverter converter to recharge the high voltage battery. So on MG1 it was 273.6 was the maximum output of MG1. Now it's up to 500 volts on while it's generating while you're driving, so it can recharge the high voltage battery more quickly and provide extra power to MG2 to help propel the vehicle down the road. MG1's rotational maximum speed is still 6,500 RPM, and that does not occur until real close to the maximum vehicle speed of 103 miles per hour on this vehicle anyway, with the factory size tires of 195/60 R15 tires. So with all of the gear ratios taken into consideration, MG2 is right at 5,755 RPM at 103 miles an hour. The speed of MG1, of course, can be varied based on the rotational speed of the internal combustion engine, which will, once we get this assembled, we'll look more closely at that. All right, let's take a look at a few other pieces that are different. For MG2, I've got an MG2 rotor that we've partially disassembled, and then I've got the one that comes out of this transaxle here. And what I want you to see is that they made a change to the placement of the magnets in the rotor itself. So if you look at this these laminations, this whole piece right here is nothing more than a whole bunch of these laminated metal plates with the magnets stuck down inside of these V-shaped grooves. Well, the V-shaped grooves are new for 2004 with the second generation Prius. Okay, if you look at the slots in the laminations of MG2's rotor, you can see that there's these V-shaped grooves, and the magnets on the second generation Transaxle, the P112, are in the V shape. You can see two magnets that are installed right here. I've got a magnet out right here that would have been in this upper area right here. The magnets in the previous MG2 rotor for the P111 Transaxle were just flat. There was no V shape involved. They were oriented like this. And so what the new product information tells us is that this V shape increases the power of the MG2 rotor by 50%. So if we take a look at the output here, the power ratings for the new MG2 rotor with the V-shaped magnets, which those V's, right, the middle center of the V occurs at every one of these notches here in relation to the resolver rotor there. We have 68 horsepower and 295 pound-feet of torque, where the previous one, keep these two separated, I'll never get them apart if they come together. The previous one was 45 horsepower and 259 pound-feet of torque. Well, if we do a 50% increase in power of 45 horsepower, half of 45, or 50% of 45, is 22.5. If we take 45 and add 22.5 to it, we get 67.5, which is the 68 horsepower that the new MG2 rotor design. Same dimensions, very, very close to the same dimensions, same diameter, thickness, just a little bit thinner on this one, but 50% more power, which of course a customer would notice, especially if they came from the first generation Prius. You would certainly notice an increase in power of 50%. Another thing they did on the second generation Prius is they bumped up the voltage that MG2 could generate during regenerative braking to 500 volts also, where the first MG2 rotor in the P111 Transaxle could only put out the 273.6 volts. So we've increased, as far as the rotors, the electric motor rotors, we've increased the rotational maximum speed of MG1 from 6,500 RPM up to 10,000. We've increased the torque of MG2 by 50%. We did not increase its rotational speed because we don't need to. The maximum RPM is reached at well beyond a legal speed limit anyway. All right, so let me get these rotors out of the way. Another major change for the second generation Prius Transaxle, the P112, was to go to the Toyota WS transmission fluid rather than the Type T4 fluid. This WS fluid has lower viscosity, which reduces losses and increases fuel economy. All the changes made between the first and second generation Prius resulted in a 15% increase in fuel economy, which is pretty impressive. So the Type 4 fluid is gone. The WS fluid is the new fluid. And that's what we use clear up through today with the new P610 transaxle, is this WS fluid. All right, another thing they did is made changes to the final drive gears themselves. As you can see here, over here is the final drive for the P112, the second generation Prius. This is the final drive for the P111, the first generation Prius. Notice the width of the ring gear is much smaller than the width of the ring gear on the new one. These have exactly the same gear ratios, the 2.885 to 1 versus the counter-driven gear pinion gear, but the second generation Prius has an overall higher numerical gear ratio, which gives us more torque multiplication, which makes it feel like we have more power, even though the internal combustion engine for the second generation Prius is the same engine as the first generation, and it has the exact same amount of power and horsepower and torque, but it feels like it has more power now because of the overall combined, remember the 4 different gear reductions that take place in the transaxle. They made a change on the second generation Prius to where the final drive gear ratio now is 4.113 to 1. 4.113 turns of MG2 to get 1 turn of the final drive, which turns the same speed as the tires. Now, that's 4.113. The previous generation was 3.901. So not a huge change, but enough of a change. Now, how did that change take place if the final drive gear ratios are the same? Well, what they did is they made a change to the chain and sprocket configuration. The second generation driven sprocket only has 35 teeth, where the first generation driven sprocket had 36. The second generation drive sprocket, this piece here, has 36 teeth, where the first generation, the P112, had 39 teeth. So that is the part that accounts for the difference in the overall final drive gear ratio, is the number of teeth in the sprockets. Now, by making that change in the number of teeth of the sprockets, they also had to change the length of the drive chain. The drive chain links in the P111 were 74 links, and in the P112 are 72. So they reduced 2 links as a result of changing the overall gear ratio. So let me get the chain and sprockets out of the way. Another change they made was to the counter-driven gear, the gear sizes and the bearings themselves. As you can see here on the first generation P111 transaxle, they had taper roller bearings, some fairly small thickness gears for both the counter-driven gear and the equivalent of the pinion gear for the final drive. So 2 tapered roller bearings. These, which I forgot to show you in that first video, have to be preloaded. There's special shims and special measurements you have to take to preload the counter-driven gear as well as the final drive. On the second generation transaxle, the P112, it's the exact same gear ratio, but notice now they have ball bearings, great big ball bearings to support this counter-driven gear rather than the tapered bearings, and the gear width is much wider. So it's what I'm trying to say is it's a more heavy-duty transaxle, although at first glance they look almost the same, and they have almost exactly the same gear ratio from one transaxle to the other in some of these parts. All right. Another change that took place was with the flywheels and the clutch damper springs. If you recall, the first generation Prius has a flywheel, a clutch style disc that's permanently applied. We talked about how all that works in the first Transaxle video on the P111. The damper springs here on the first generation Transaxle are extra stiff. And what they tell us in the documentation for the second generation, the P112 Transaxle, is that they made these springs less stiff. As a matter of fact, there's only a single spring in these two side pieces where there's two springs in the first generation Transaxle. They also tell us that they've lightened the flywheel. So this flywheel here is about 1.5 pounds lighter than the first generation Prius flywheel. All right, another change to notice is on the case here on the P111, the first generation Transaxle. The cover that covers the MG2 rotor inside the Transaxle has this cast iron driven sprocket support inner bearing race. This whole piece right here was an additional piece that has to be bolted on to the aluminum cover that covers MG1. The second generation Transaxle, the P112, notice that cast iron housing is gone and the bearing support is part of the aluminum housing, and what they have is a steel sleeve that's pressed on for the driven sprocket support bearing to rotate on. So that made it a little bit lighter weight. All right, while we're here also, another change that took place was in the cables for the three-phase cables for the MG1 and MG2 stators. The cables here for, let's see, this was for MG1 right here, are much smaller diameter than the cables for the first generation Prius, the Transaxle, the P111. So if you look at these giant wires here, so the diameter of these wires is pretty large, and that's because we used a lower voltage, the 273.6 volts, which made us use higher current to get the same amount of power delivered to the stator. Well, by going to the 500 volt system on the P112, we could go with a higher voltage but lower amount of current and still end up with the same amount of power, because voltage times current gives us power in watts. By comparison, I've got a cable that's cut away here just so you can see. You can see there's quite a difference in the diameter of the of the cables that feed the stators of both MG1 and MG2 on this second generation P112 Transaxle because of the higher voltage for both MG1 and MG2. Okay, another change that took place for the P112 Transaxle is we got rid of the shifter linkage and the shift cable and went to a shift actuator control motor to let the computer put you in park or take you out of park. So this really just puts you in or out of park. Reverse is done electrically. It has nothing to do with the position of the parking pawl, other than the parking pawl needs to be released. So the shift actuator control assembly is a brushless motor that turns the same shaft that the mechanical linkage used to turn, here on the top of the transmission. On the top of the transmission, where they used to have shift linkage, it's just a steel plate. There's nothing there anymore. They just put a cover over it and let it be. This motor has a position sensor built inside of it and a unique little gear drive system that allows it to multiply torque and let a little electric motor move the gear selector shaft to put us into or take us out of park. All right, let's see if there's anything else on this case that we want to talk about that's different. Oh yeah, notice there is no oil pan. Like on the bottom of that P111 Transaxle, we had the black oil pan. You took the pan off, there was the filter screen in there for the oil pump. All that's gone. Instead, now all we have is the Transaxle drain plug right here, and the Transaxle fluid level check plug over here. This Transaxle holds less fluid also than the P111 Transaxle. The P111 held 4.6 liters. This holds 3.8 liters. So a little less fluid, a little lighter weight. Another thing to notice is the coolant pipe fittings here on the side of the Transaxle are pressed in fittings rather than the threaded in ones like we had on the P111 Transaxle. We've still got a Transaxle fluid fill plug here on the top of the Transaxle. It's just in a little bit different location. All right, here inside the center case, we have the same oil catch system and lubrication drains to lubricate all the bearings in this Transaxle. There's a selective shim in here underneath this final drive differential case bearing right here to set the preload. There was on the first generation also. I forgot to mention that. You can see our oil pump pickup screen right here in the bottom of the case now rather than in the oil pan like on the first generation. And the drain plug right down here for the fluid has a magnet built into the plug itself. So if you recall on the P111, there was a magnet in the bottom of the black oil pan. They've moved that magnet to this drain plug right in the center of that drain plug. All right, let's turn this around and take a look at the identification of this Transaxle. All right, you can see right here is the 3-digit identification code that we talked about on the first generation Transaxle, the P111. It had a 2CM code. Notice this one on the P112 is a 3CM code. This code is in a different location. It's down here by the final drive CV shaft on the driver's side of the vehicle rather than on the front of the Transaxle next to the coolant pipes is where that 3-digit code was on the P111. Oh, right down to the bottom here, you can see the pickup tube for the oil pump. It's in the same location as the pickup tube was on the P111. That goes to the rear cover, which has the oil pump in it. So let me get this out of the way. Oh, before we look at the oil pump, this temperature sensor for MG2 has a built-in temperature sensor into the stator of MG2. But this electrical connector here has 6 terminals now. 4 of these terminals are used. 2 of the terminals are for a temperature sensor built into the stator. The other 2, if you follow the wires down, go to a temperature sensor right here in the bottom of the case, which measures this one right here, measures the fluid temperature of the Transaxle. So they added that temperature sensor and got rid of the temperature sensor that was in the MG1 Stator. Once again, I have no idea why. All right, now let's look at the oil pump assembly and the rear cover. Here's the rear cover for the P112. Here's the rear cover for the P111. And at first glance, you'd be hard-pressed to find any difference between these two covers, other than this one's darker, more oxidation. They use the exact same dimensions of oil pump. We have the pressure tap, a pressure relief valve in the same location on both models. We have the little plug that we talked about to get in and tweak the adjustment on the resolver. On the P112, those resolvers are not supposed to be removed. They are factory calibrated. And as we talked about in that first video, if you remove those, the computer will not be able to tell where the magnets are in the MG2 rotor or MG1, depending on which resolver you've removed, versus the position of the stator windings. We need the computer for the controlling the rotational speed and torque of the electric motors needs to know where those magnets are so that it can actuate the proper stator windings at the proper time to pull it around. So I believe, as I mentioned in the P111 video, that these are adjustment holes for factory calibration. The only difference I can see here between these two is that on the first generation Prius, if the oil pump pressure was excessive, the pressure relief valve would open and it would send oil back down into the bottom pan. Where here on the second generation Prius, they got rid of that passage and they just simply put it back into the inlet, the suction side. It does the same thing. So I believe that made it a little bit lighter weight, this rear cover here. Now, I have, with our bandsaw here, cut a groove across here so that when it's bolted up for my students to see, they can look in and see part of the stator windings and the resolver and so on. But other than that, I don't see any difference between the two oil pump covers. They have the same pressure test, the same requirements there. All right, just a few other things to look at as far as differences, and then we'll finish putting this together. The MG1 Cooling Passage bleed tube here is in the same location as it was on the P111. The vent, however, has been moved to the cover for the MG1 electrical connection, where it used to be over here on the side. Everything else we've talked about or is the same. However, I want to show you the inside of this bell housing area. As you can see on the inside of this bell housing area, this is the transaxle where I removed the coolant passage plug for MG1. If you recall, the MG1 Stator sits right here in these open passages. I don't put it in the passages here on my cutaway transmissions because it prevents me from rotating the rotor because of the magnetic field strength. But that stator is cooled by the coolant passages that go all the way around that stator. And this plug sits up in here and has a snap ring that holds it in place. And I removed that just for an experiment with using compressed air, blowing it out through the coolant passages. But in the process of removing that, it ruin the big O-rings that seal that off. And so, as I mentioned in the first video on the P111, never ever remove this, because unless you've got a source to replace those O-rings, you're going to have a coolant leak when you put that thing back together. So you got to be very careful with that. Let's just take a quick look at how to assemble the major gear components of this transaxle, and then we'll take a look at the overall gear ratios that we talked about here in the deep dive. All right, so the first thing to install is the counter-driven gear with its new ball bearings, the big heavy-duty ball bearings. We used to just have tapered roller bearings there instead. There we go. The temptation here is to get a hammer and tap down on it, but nobody in their right mind would tap on a bearing. But yet if you tap on this gear, then you're tapping on the bearing that that gear is pressed onto that goes down below, and you'll end up creating a condition called brinaling. And so just vibrating it back and forth, wiggling it back and forth, is the best thing you can do to get these things in here if you don't want to ruin a good bearing. All right, so now let's get our driven sprocket and our drive sprocket installed. That goes next. We've got our dark link facing up, which is how it was when it came apart. And just like on the P111, this has to go down with the chain as horizontal as you can get it. And so the chain wants to fall down over there, and as it falls down, it pulls this gear that way and binds up the bearing in the bore. I can see that the shaft is pushed in that way too far. There we go. If I pull it back. The chain should be tight. It's still back too far. Now, I'm breaking my own rule here with the hammer, but I'm not going to hit down with this hammer. The problem that occurs is that the shaft gets tilted in. And so if we can, there we go, just tip it back up vertical, then we're down in. I wasn't strong enough to do that on my own. Okay, so the next thing is our final drive gear differential case. By the way, the parking linkage on this transaxle is exactly the same as the P111, except for the electric motor that actuates it. All right, so we've got our chain. So we've got our drive sprocket, our driven sprocket, with our counter drive gear, driving the counter driven gear, driving the pinion gear, driving the final drive gear, and the overall gear ratio of all of that is 4.113 turns of MG2 to 1 turn of the tires and the final drive ring gear here. If you recall from the P111 transaxle video, the MG1 rotor turns the power split device sun gear, one of the three parts of our planetary gear set. We've got a sun gear, a planet carrier right here that turns the same speed as the engine, and then MG2 back here that drives the ring gear that turns the same speed, or not the same speed, but it when it moves, it makes the tires move. All right, so let's put our flywheel up inside. There we go. And then our planet carrier splines to the flywheel. So as the flywheel and clutch rotate, it turns the planet carrier. And then we've got the ring gear right here, the ring gear that MG2 drives. Make sure I've got the bearings in place there. Notice it slots right down into the chain drive sprocket, and it's got some we're missing a there it is. It's got some splines down inside there that'll spline right to the MG2 rotor. So let's bring that rotor over here with its V configuration magnets. And there we go. So just like the P112 Transaxle in the first generation Prius, we have an inline axis hybrid drive system here. Both electric motors, MG2 and MG1, are in line with the center line of the engine crankshaft. MG2, also referred to as a traction motor, is what moves the vehicle down the road. It's always going to rotate if the vehicle's moving, and the vehicle cannot move unless we rotate MG2. MG1 is both the starter motor. Notice if I rotate MG1, it causes the flywheel here to rotate. And it also, when the engine is running, notice the flywheel turns MG1 and makes it be a generator. And it's got a 2.6 to 1 gear ratio there to cause that to rotate faster than the engine. We have, as we mentioned before, 50 kilowatts of power, 68 horsepower, 400 newton meters of torque, which is 295 foot-pounds of torque, which is pretty impressive. The forward rotation of the vehicle is in this direction, and it should take 4.113 turns of the MG2 to get 1 turn of our final drive gear here. So let's try it out. We'll watch the stickers here. There's 1, 2, 3, 4, and just a tenth more, 4.113, to get 1 rotation of the final drive. Just like on the P111, the engine flywheel is not connected to MG2. The engine does not make the vehicle move down the road. MG1 does not make the vehicle move down the road. It's the combination of controlling the speed of MG1 and the engine that allows, through the planetary gear set, the engine to contribute torque to help rotate the MG2 motor. Notice if I hold MG1 still and turn the flywheel, MG2 also rotates. If I let MG1 slip a little bit, it doesn't turn it as much. So by controlling the rotational speed of MG1 with the engine running, we can control how much torque the engine delivers to MG2 to help power the vehicle down the road. MG1 is a generator, and when the high voltage battery, which on the second generation Prius is at 201.6 volts, which is 72 volts lower. They took out 10 of those flat pack battery cells of 7.2 volts each and dropped the voltage down to 201.6 volts. When that battery voltage starts to get low, which it's bumped up to the 500 volts to help drive MG2, the engine can spin MG1 faster or slower, depending on what it needs to do, to generate power off of MG1 to deliver to MG2, and also any leftover go back to the battery to help charge the 201.6 volt battery. So pretty much the exact same operation, just a more powerful MG2, a different gear ratio that gives us more turns of the rotor, MG2 rotor to one turn of the tires, which gives us more torque multiplication, gives you more acceleration, gives you more torque, and a higher speed, up to 10,000 RPM. If we need to really generate some power, we can crank the engine speed higher or lower depending on the rotational speed of MG2 to get the power that we need to move the vehicle down the road. They really did a lot to make sure that you did not go into the turtle mode. The first generation Prius had a turtle mode where a dash light of a turtle would come on that would indicate that you were out of battery power and that it was all the engine turning MG1 could do to generate power to run MG2. That rarely happened unless you like those magazine articles I talked about at the first of this video, or driving up a super steep long mountain pass. But that turtle light is gone in the second generation Prius. Higher voltage, higher power, stronger magnets, stronger, higher torque motors. All right, let's see, is there anything else? Let me just check my notes here at the differences between these two. The overall height of this transaxle is the same as the P111, so those are equal. But the weight has been dropped by, looks like, 8.5 pounds. This one only weighs 236 pounds versus the 244.5 that the that the P111 weighed. Okay, this has been a review of the overall operation of the second generation Prius P112 transaxle. We did a comparison of the P112 to the previous P111 that came in the first generation Prius, and there was and reviewed the considerable differences between the two. The second generation Prius has quite a following. It was sold for 6 model years and has a pretty good reputation of being a good, reliable car. Battery life, I've helped a couple of people that I know change batteries in theirs. They were around 160, 170,000 miles, and they were both 10, 11 years old. And that's here in Utah with our hot and cold climate. I don't know how they are holding up in other parts of the country or the world, but it seems to be a really good transaxle design and nice hybrid system. But it gets even better. In the next episode, when we take a look at the third generation Prius transaxle, the P410, we take it to a much higher level of power and efficiency, and I look forward to reviewing that transaxle with you also. All right, there's one more thing I need to show you that I forgot to show you in the P111 video, and that's in regard to the shifter positions for these Prius transaxles. All of the shifters for all 4 generations of the Prius have a B position. So there's park, there's reverse, there's neutral, there's drive. So what happens in the drive position, the D position on these transaxles, is when you slow down, when you decelerate, MG2, which, if you recall, drives the vehicle, is a set of spinning magnets. It's 8 rows of spinning magnets inside of the stator assembly, which is 3 coils of wire. And that induces current into these coils of wire, which it physically slows down the rotor from spinning, because the induced currents into the stator create counter electromotive force that actually creates a repelling magnetic field to the rotor, to the rotation of the rotor. So it physically slows it down. It makes it harder to turn. In the B position, the braking position, both the MG2 and the MG1 rotors go into regenerative braking. So apparently in the drive position, it's just MG2 that does regenerative braking. In the B position, you've got 2 electric motors doing regenerative braking at the same time to help slow you down. But of course, MG1 is maybe half the size or less than MG2, so it's not going to be a huge difference, but it does make a difference when you slow down, or it can make a difference. It really just depends on the state of charge of the high voltage battery. If the high voltage battery is already charged, then there's not going to be a lot of regenerative braking going on, because there's no place to put that extra electrical energy. But if the high voltage battery is in need of a charge, then of course there's some place to put it. Now, if you're still going down a mountain pass and you have the regenerative braking going on either on one or both motors in the D or the B positions, then what happens instead is we use that current to rotate the MG1 rotor to spin the crankshaft of the engine. So we dissipate that electrical energy by cranking the engine. The fuel system is disabled when that happens, and so it just cranks the engine. The engine won't start, but it allows that electrical energy to be dissipated. You can't just spin a magnet inside of a coil of wire and not have the electrical power go somewhere. It either has to go to the battery or be used some other way. And so that's what happens here in the B position. 2 motors in B, 1 motor in D. By the way, if you put it in neutral and coast, there is no regenerative braking that takes place at that time. It will not charge the battery. It will not regenerate either. I'm not sure electrically what happens, because you're still spinning a set of magnets inside of a coil of wire. It's possible that the resistance is just turned up really high in the controllers for the stator, and it just creates extra heat instead of charging the battery or cranking the engine over. But neutral position does not give you any charging. Just a few minutes of additional trivia here on the evolution of the Prius and the early transaxle. If you recall from the P111 transaxle video, I showed you the 3-digit codes that identify the transaxles. And the first generation Prius had a 2cm transaxle in it, and I showed you reference to a 1cm transaxle. Well, the 1cm transaxle apparently is the transaxle that was used in the Japanese version of the Prius. And when Toyota did some early marketing and testing here in the United States, they let automotive magazine writers drive the Japanese version of the Prius that I'm pretty sure had that 1cm transaxle in it. I have found several different magazine articles from 1999 and 2000 from writers of automotive magazines here in the United States test driving the Japanese version of the Prius, which is a right-hand drive. I've got 2 of them from Auto Week, and it's obvious to me that that driver or that rider did not like the Prius at all. I've got one from Car and Driver that gave it a fairly decent review, and another one from Motor Trend that gave it a fairly decent review. However, every one of these articles refers to what's known as a turtle mode. And the turtle mode was where an icon of a turtle actually was illuminated on the dash when the battery power got really low enough that there wasn't enough power to drive the vehicle normally. Now, normally the internal combustion engine would turn MG1, the motor generator number 1, which would generate enough power to keep the battery somewhat charged, but more importantly, provide enough power to MG2, the great big electric motor, to propel the vehicle down the road. Well, of course, all of these people out driving the vehicle decided, well, let's see what its top speed is. So they run it up to 99 to 100 miles an hour, and then the turtle mode comes on, of course, and then it starts losing power, as if that's a everyday driving condition. Another one from Auto Week took it up a huge mountain pass during some race, climbing Mount Washington, and then wondered why it was going into the turtle mode. As a matter of fact, they misunderstood how the Prius was supposed to operate, and when the battery power got down to where the turtle mode light came on, they thought they needed to pull over to the side of the road and let the engine recharge the battery before they could go any farther, which of course is not how it was intended. And later on in the article, they realized that was their mistake, and they actually admitted that they didn't understand how the car was supposed to work, and that they could have kept driving because of the MG1 recharging the battery. But I believe because of these articles, many of these articles, and I'm sure there's more that I haven't seen, these articles gave users or potential buyers here in the United States the impression that the Prius didn't have any power. For many, many years, I've fought with, not really fought with, I've argued with people that said, well, I heard those don't have any power. I'm pretty sure that came from these articles here, because if you were to actually go drive one, which is what I ask them, have you driven one? Because once you've driven one, you normally wouldn't have that complaint. But I want to read you a real quick thing here from Auto Week, March 8th of 1999. This writer, this Kevin Wilson, who wasn't impressed at all with the Prius, or the need for it, because gasoline was so cheap at the time. The last paragraph in his article here, he says, "Think of everyone you know who owns an iMac computer. There's Toyota's target market. People who buy the latest cool technology because it's the latest cool technology. Within that subset of the population is another group of people that bases individual buying decisions on hair-shirted interpretation of what's good for the public weal, voluntary guinea pigs for the automakers' experiment in the future of automotive science. We are not raising our hands yet." Kevin Wilson, which I thought was pretty funny. So a lot of bad press, a lot of mixed press, and unfortunately for Toyota, they let the Japanese version of the Prius be driven over here instead of the marketed or the real version that would have been sold. And so I think that was bad in a way because of the bad press, but it was good in a way because they got some really good feedback that the Japanese version couldn't go 100 miles an hour or up Mount Washington without going into the turtle mode, or across the desert in another one of these articles in Nevada or Arizona without going into the turtle mode. All right, a couple other trivial things with the Prius and their marketing. There are several ads that they put in automotive magazines when the 2001 Prius came out. I've got several of these that I've collected, and one of these answers a question that has been bothering me for years. Here on campus here at Weber State University, we've had a Toyota training center for more than 20 years. And over on the training center door, since as long as I can remember, I've been here since 1991, but I think it showed up when the first generation Prius training for technician training came along, probably in the year 2000. There's a label on the door over to the office of the Toyota Training Center that reads, "Eat my voltage." And I've always wondered, what does that mean? In a way, I thought it was kind of cool. I thought it had something to do with electrical training that was going on at the Toyota Training Center. But then when we got our first generation Prius over here, in the back window right above the speaker shelf is that same sticker saying, "Eat my voltage." And I thought, what is going on here? What is the significance of the "Eat my voltage" sticker there? And so I did some research online, and I actually found the ad from Toyota for the 2001 Toyota Prius that shows a Prius passing a semi-truck on the road, and it reads, "Eat my voltage" down below. And I'm not really sure exactly what that means. I've done some reading through some of the online chat boards and so on, and some people think it's analogous to "eat my dust" when you pass somebody really fast or whatever. So "eat my voltage," I guess, refers to that it's partially powered by electric power. I don't know. I thought it was kind of funny, but it finally answers the question of why is there a sticker in the back shelf of the Prius here and in the Toyota Training Center. It doesn't really explain what it means here in the article, but at least I see a tie to it now that it was certainly related to the first generation Prius. Okay, well, there's a couple of other ads showing the energy monitor and the fuel economy and clean emissions and so on of the first generation Prius. And as we've seen in this video here, the second generation Prius was greatly improved over that. Thank you for watching.